Hello students, today we are going to start with the first chapter from class 11 physics mechanics. The chapter name is kinematics and it's divided into two parts. One is motion in one dimension, where we study the motion of bodies moving in a single straight line, and the second one is motion in two dimensions, which will be the next chapter. So we shall start with the study of one dimensional motion first, and we develop the concept of motion of bodies and different types of motions in this chapter. So we start the chapter by discussing what we call as the state of rest versus the state of motion of a body. So how do we define rest, a body at rest? We understand that if there is a body which does not move with time, which does not change its position, it stays where it is, right? The body is said to be at rest. Whereas if we have a body which shifts its position from one point to another, for example, this is another body which is initially at position A, and after some time if it is found to be at another position, a new position B, we can say that this body has shifted, it has moved from position A to position B. So the body has been in motion during some time, right? So it is essentially with respect to the position of a body that we define the state of rest or the state of motion of a body. If the position of the body changes with time, we say that it is in motion. If it does not change with time, we say that the body is at rest. Once we understand this, we go next into understanding the difference between what we call as distance travelled by a body versus its displacement. Distance travelled versus displacement. So to understand this, we shall take the same example of a body which was, let's say, at position A initially, and finally it is found to be at some other position B. Now in general, in order to move from A to B, the body can take any path, right? It not necessarily move along the straight line joining A and B. It can take any path, maybe there are other paths available, and the body moves like this to move from A to B. In that case, the length of this whole path that the body has taken in order to reach from the initial position A to the final position B is called the distance travelled. So by definition, distance is the total path length covered by the body in the process of its motion. Okay. So understand that since it's a length, we are going to measure a length in the process of measuring the distance travelled. It is a scalar quantity. That means it has only a magnitude, not a direction associated with it. Then what is its SI unit? Its unit that we generally use in questions is meters. The SI unit is meters, written in short as M, and we denote it by a letter S. It is denoted by a small s, just a small s, nothing else. So if we have to write distance in short, we will simply write it as S. In questions you will find this being mentioned like this. So just by looking at this term, we understand that we are talking about the distance travelled. Next is displacement. Displacement by definition is the shortest distance between the initial and the final position. So if A is the initial position of the body and B is its final position, what will be the shortest distance between them? I hope you all understand that it will be the straight line joining the point A with the point B. This will be the displacement. Not just that, displacement has a direction associated with it. Displacement points from the initial position to the final position. So as I have drawn this arrow over this line, you understand that displacement is a vector which points from the initial position to the final position. So from A to B in this particular case. So displacement by definition is the shortest distance between the initial and final positions, and it is a vector. That's a major point of difference between distance travelled and displacement. It's a vector quantity whose direction is from the initial position to the final position. Its SI unit is the same as that of distance. SI unit is meter itself, written in short as m, right? And how do we denote it? We denote it using the same letter S. But this time, since this is a vector quantity, we'll put a small vector sign over it. So vector S denotes displacement of a body moving from one position to the other. Now let us understand these two terms more clearly by taking a few examples. Example 1. Let's say we have a body which moves along a circle. This is a circular path, and this circular path has a radius, let's say r. Now it is given to us that the body starts from position A and moves through this circular path to reach the diametrically opposite point B. In the process of moving from A to B, we are supposed to find out the distance travelled by the body S and the displacement of the body S vector. So how do we proceed? First, we can look for the distance travelled. As the body moves from A to B through the circular path, we understand that the distance travelled by the body will be nothing but the length of this half a circle, isn't it? We know how to find out the length of a circumference of a circle, right? So it's just half of that, right? Isn't it? So can we say that the distance travelled by the body here, S, will be the total circumference of a circle divided by 2. It's half a circle from A to B. So it will be just pi r meters, if r is given in meters. And then the displacement S, do you see what will be the displacement here in this case? The displacement here will be the straight line joining the point A to the point B, which is nothing but the diameter of this circle, isn't it so? So the displacement here in this case will be twice of the radius. The diameter is twice the radius, so 2r, and we have to mention its direction also because we are right now discussing a vector. So 2r from the point A to the point B. It points from A to B. This is one way of expressing the direction of this vector. There could be other ways also. So for example, if we consider the rightward direction as along the x-axis, we know that there is a unit vector associated with the x-axis, I cap, right? So if we want to express it in that form, we can write the same displacement vector S as 2r I cap. That will also work. But before that, we have to mention that from A to B, this vector is pointing actually along the x-axis, if we take the x-axis along the same direction. So it depends upon how we put the reference for a direction that we can express our answer. Another example that we can take here could be a particle that initially is at point A. It travels a certain distance, let's say it travels a distance of 4 meters towards right to reach a point B, and from the point B it takes a left turn. So it was moving from A to B like this, and then it takes a left turn, so it moves like this now, and let us say it moves a distance of 3 meters further from B to reach the final position, which we can call as C. And the question is the same. We are supposed to find out the distance travelled by this body as well as the displacement. So this time, do we understand that the distance travelled S will be the length AB plus the length BC, the total path length covered by the body, which in this case will be 4 meters plus 3 meters, that's 7 meters. Distance travelled is 7 meters. What about the displacement? For the displacement, we have to join, using a straight line, the initial position with the final position. See that initial position is A, final position is C. So when we join the two, this is our displacement vector, the vector AC. How do we express vector AC as our displacement vector? The displacement vector S, which is nothing but the vector AC. Do you understand? It can be represented by using various ways. So we can look at how we can express it. One way could be, once again, if we take the rightward direction as along the x-axis, knowing that there is a unit vector I cap pointing along it, and the upward direction as along the y-axis, knowing that there is a unit vector associated with the y direction, which is j cap. Do we see that this displacement vector AC is essentially made up of two displacement vectors AB and BC. So vector AC can be written as vector AB plus vector BC. This is coming from the triangular law of vector addition that we have studied in vectors already. Vector AB, see that we can write it as 4 meters I cap, whereas the vector BC can be written as 3 meter j cap. So this becomes your vector AC, the displacement vector S. Now we can go a step further and try to find out the magnitude of the vector S. Magnitude of vector S, which comes from understanding that if a vector is given in its rectangular component form, its magnitude can be easily found by using the Pythagoras theorem. Here in this case, if we see that AC, the length AC is nothing but the hypotenuse of this right angle triangle ABC that we are getting here, we understand that the length AC would be nothing but the square of length AB plus the square of length BC. So it will be 4 squared plus 3 squared over here, which is nothing but 5. So 5 meter is the magnitude of the displacement vector AC. This length is 5 meters here. So we can get the magnitude of our vector, displacement vector, as well as its direction. Direction you can get from this form of the vector, right? So that way you can find out the displacement vector both in vector form as well as if you want to get its magnitude, you can get its magnitude as well. Let's take one more example here. The next example is, there is a particle which moves along the arc of a circle. So this is, let us say, the two radius vectors joining the point A to the point B, the initial point to the final point, and this particle moves along the arc of this circle whose radius is r. So this will be the center of that circle and the particle moves from A to B. You can see easily that this curve AB is a part of a circle, right? The question now is, you are supposed to find out the distance and the displacement of this particle when it is given to you that the angle that this arc subtends at the center of the circle is theta. The angle theta is given, the radius of the circle r, which is the length OA or OB, that's given, and we are supposed to find out the distance travelled by the body as well as its displacement. So how do we proceed? For the distance travelled, which will be nothing but the length of this arc AB, if we just draw this length once again, it is this length that we are looking from A to B, the part of the circle. How do we get this length? Do we all know that if we complete this circle over here, if we complete this circle like this, then the total circumference of the circle will be 2 pi r, and this is for a total angle that the circle subtends at the center as 360 degrees or 2 pi radians, right? So for an angle of 360 degrees subtended at the center O, which is also 2 pi radians, 2 pi radians of angle creates an arc length of 2 pi r, which is the complete circumference. We are trying to find out that arc length which subtends an angle theta instead at the center. So we can use unitary method here. We will say that if an angle of 2 pi creates an arc length of 2 pi r, then an angle of theta will create an arc length of theta by 2 pi times 2 pi r, isn't it? Which will be nothing but 2 pi cancels out and you are left with r theta. So, r theta is the length of this arc AB from A to B as it subtends an angle theta. We all know that this is also a standard result. In case of a circle, if we ever want to find out the length of an arc which subtends an angle, any angle theta, let's say at the center, if this angle is theta and the radius of the circle is r, we know that this arc length is given by r into theta. So, the same thing we are getting from here. So, the distance travelled in this case will be nothing but r theta, right, where theta has to be in radians. Theta is to be in radians here. This is important. If it is in degrees, you have to first convert it into radians and then you need to work upon it. The second case, finding out the displacement of this particle, the displacement vector S. Now, to find out the displacement, let us first see what displacement here is in the figure. The displacement here is the shortest distance between A and B, which is the straight line joining the points A and B. This is the displacement, isn't it? So, how do we get this length AB, the straight line AB, the length of that? We can do a construction over here in this figure to get this length. What is that? We start from the center of the circle, the point O, and we drop a perpendicular from the point O onto the line AB. See that since both the radii are equal in magnitude, OAB is an isosceles triangle with its two sides equal, and when we drop a perpendicular from the point O onto the side AB, it will bisect the line AB. It will be perpendicular to the line AB as well as it will bisect the line AB. So, let us say it bisects it at the point D. Now, look carefully that the two triangles that we are getting here, the triangle OAD and the triangle OBD, both are similar triangles, they are actually congruent and both are right angle triangles. So, if we can find out the length AD or the length BD, any one of these lengths, we can easily double it to find the length AB, which is what we are looking for, the displacement. Now, how do we find the length AD? To find out the length AD, we can observe that this triangle that we have OAD, this is a right angle triangle over here, and in this right angle triangle, we already know the length of the hypotenuse, which is nothing but the radius r, and we know the angle that this triangle has, one of the angles which is here theta by 2, half of the total angle that the arc was subtending, right? So, if we consider this particular triangle over here, the triangle AOD in triangle AOD, can we write the opposite side which is AD, opposite to the angle theta by 2 is the side AD, the opposite by the hypotenuse which is AO. Opposite by hypotenuse we know is which trigonometric ratio? It's sine. So, we will have AD by AO as sine of theta by 2. Please convince yourselves of this particular thing from the figure. And then we can find out the value of AD from here. AD is AO into sine theta by 2. What is AO? AO is nothing but the radius of this circle. So, we can write it as r into sine theta by 2. Now, understand that what we are looking for is the length AB, which is nothing but double of the length AD. The length AB, this implies, which is double of length AD, will be nothing but 2 times r into sine theta by 2. And this is what we are looking for, the length AB, which is our displacement. So, we can write the displacement vector S as 2r sine theta by 2. Now, what is left is mentioning the direction. The direction is from A to B. So, this is one way in which you can write the direction from A to B. This is one way. Or another way could be that you just consider this direction as the x-axis and then you know that a unit vector along this direction is I cap. So, you can write it as 2r sine theta by 2 I cap. This is another way of writing the same answer, right.